Okay, our lesson today is to be able to use equivalent ratios and rates to solve real-world and mathematical problems. Some of the vocabulary that we will be using today. First, we have equivalent ratios. Equivalent ratios are two ratios that name the same number. They express the same relationship between quantities. Second word we'll be using today is scaling. Scaling is when we multiply or divide two related quantities by the same number. Finally, we have ratio table. A ratio table are columns that are filled with pairs of numbers that have the same ratio. All right, let's take a look at our first example. All right, our first example says to make yellow icing, you mix 6 drops of yellow food coloring with 1 cup of white icing. How much yellow food coloring should you mix with 5 cups of white icing to get the same shade? You'll see in our table that we have the 6 drops make 1 cup. If I want to know how many drops I would need to make 5 cups, I'd have to multiply the number of cups by 5. To make an equivalent ratio, we'd have to multiply the number of drops by the same non-zero number. So we multiply that by 5, or the drops by 5, and we wind up with 30 drops of yellow icing. Icing would be needed to make 5 cups. Here's our next example. In recent year, Joey Chestnut won a hot dog eating contest by eating nearly 66 hot dogs in 12 minutes. If he ate at a constant rate, determine about how many hot dogs he ate every 2 minutes. Well, I see here, if we can eat 66 hot dogs in 12 minutes, I want to know, well, how many hot dogs can I make or would I eat in about 2 minutes? Well, we start by simplifying, right, using an equivalent value. So I'm going to divide by, well, 66 and 12 are both even numbers, so I'm going to divide by 2. Right, and if I divide each of these numbers by 2, that's going to give me 33 and 6. 12 divided by 2 is 6. 66 divided by 2 is 3. Then, in order to get from 6 to 2, I can divide by 3, because 6 divided by 3 is 2. But to make or keep the ratio the same, I'd have to divide the top part of my ratio by the same amount. 33 divided by 3 would be 11, which means he ate about 11 hot dogs, right? About 11 hot dogs in 2 minutes, every 2 minutes. Right? That's what that ratio would mean. Let's look at our next example. A patient receives 1 liter of IV fluids every 8 hours. At that rate, how many hours will it take to receive 4 liters of IV fluids? I look here at my ratio table and I see the first ratio, 1 liter of fluid every 8 hours. If the question is asked, how much time will it take to receive 4 liters of IV fluid, we'd have to multiply the first ratio part by 4. To make an equivalent ratio, we'd have to multiply the second ratio part by 4 as well. So 8 times 4 would be 32. So it would take about 32 hours, right? About 32 hours, because the time is measured in hours, to receive about 4 liters of IV fluid. Let's look at example B. To make cranberry jam, you need 12 cups of sugar for every 16 cups of cranberries. Find the amount of sugar needed for 4 cups of cranberries. Well, I see my first ratio, 12 cups of sugar, 16 cups of cranberries. Right? I want to start reducing that ratio because they're both even. I'm going to divide by 2 over 2. So I'm going to divide by 2 here, and I'm going to divide by 2 here. 12 divided by 2 is 6. 16 divided by 2 is 8. To go from 8 to 4, I can divide by 2 again, because 8 divided by 2 is 4. So if I divide by 2 here, I'd have to divide by 2 again. Right? Divide by 2 again. 6 divided by 2 is 3. Right? Notice that all three of these ratios are the same. 12 over 16 is the same as 6 over 8. 6 over 8 is the same as 3 over 4. How do I know they're the same? Because I divided by the same non-zero number in both the numerator part and the denominator part of each ratio. We continue. The first few ratio tables were very simple. These ratio tables are a little bit more difficult, a little bit. So we need another method to use. It's called scaling. Sometimes you may need to scale back and then scale forward to find an equivalent ratio. Let's take a look at our first example. Cans of corn are on sale at 10 for $4. So here's my first ratio. 10 cans of corn for $4. Find the cost of 15 cans. Well, I can't go directly from 10 to 15, so I need a ratio in between. So, well, I see 10 and 4 are both divisible by 2 because they're even numbers, so I'm going to start by dividing by 2. Right? To make an equivalent ratio, I'm going to divide by 2. 10 divided by 2 is 5. 4 divided by 2 is 2. Now, to go from 5 to 15, I'd have to multiply by 3. So I'd have to multiply the denominator part of my ratio by 3 as well. 2 times 3 is 6. So first I have to scale backwards, or scale back, using division, and then I scale forward using multiplication. And I'm able to come up with my answer of $6 for 15 cans of corn. All right? And that's what we see here, right? We would do the same thing there. We continue. Joe mows lawns during his summer vacation to earn money. He took 14 hours last week to mow 8 lawns. At this rate, how many lawns could he mow in 49 hours? Is there a whole number by which you can multiply 14 to get to 49? The answer to that is no. So we want to scale back first, right? Because I can't go from 14 to 49. But because both 14 and 8 are even numbers, I know that I can scale back by 2. So I'm going to divide by 2 here, and I'm going to divide by 2 here. 14 divided by 2 is 7. 8 divided by 2 is 4. Now I can scale forward. From 7 to 49, we can multiply by 7. So I'm going to multiply this ratio part by 7 as well to make an equivalent ratio. So 7 times 7 is 49. 4 times 7 would be 28. So it would take about 49 hours to mow 28 lawns. Right? Let's continue. Right? Let's fill that in. 28 lawns in 49 hours. Let's look at our next table. A child's height measures 105 centimeters. Estimate her height in inches. Well, once again, I can't go from 25 to 105, but I see that both 25 and 10 are divisible by 5, so I'm going to scale back by 5. So I'm going to divide by 5 here. I'm going to divide by 5 here. 25 divided by 5 is 5. 10 divided by 5 is 2. Now I can scale forward from 5 to 105, right? By multiplying 5 by 21. That's going to give me 105. But if I multiply by 21 in the top part of my ratio, I have to multiply by 21 in the bottom part of my ratio. 2 times 21 is 42, right? So her height in inches would be about 42 inches. Let's continue. On her vacation, Leah exchanged 50 American and received 60 Canadian. Use the ratio table to find how much money, Canadian dollars, she would receive for 20 American. So we set up a ratio table and we use scaling to find the desired quantity. Well, our first step says to divide each quantity by a common factor of 10. So let's divide by 10 because they both end in zeros. So I'm going to divide by 10 here. Then I'm going to divide by 10 here. 60 divided by 10 is 6. 50 divided by 10 is 5. Then I want to multiply to go from 5 to 20. We'd have to multiply by 4. So first we scaled back by 10, and now we're scaling forward by 4. But if I multiply the bottom part of my ratio by 4, we'd have to multiply the top part of our ratio by 4 as well. 6 times 4 is 24. So we'd get about 24 Canadian dollars for 20 American dollars. All right. Next problem. Right? You have some guided practice problems here where you could take a look and practice these ratio tables on your own. Right? I can't go from, actually, I can go from 1 to 4. Right? If he earns $7 a week, how much does he receive in 4 weeks? Well, I can go from 1 to 4 here. Right? Although I think they want us to go from 2 to 3. Right? So if I go from 2 to 3, that's times 2, so that's 14. Right? This would be times 3, so that's 21. And this would be times 4. So this would be times 4. So that's going to be $28 in 4 weeks. Here, right, if I look at my next example, I can go from 8 to 2. Right? So I'm going to skip this middle step here because from 8 to 2, I can divide by 4. 8 divided by 4 is 2. So to make an equivalent ratio, I can divide this by 4. So we can skip this step if we can. Right? 60 divided by 4 is what? 15. So how long would it take her to run 2 kilometers? 2 kilometers would take about 15 minutes. Let's look at example 3. Lamika buys 12 packs of juice boxes that are on sale, pays a total of $48. So for 12 juice boxes, I'm going to pay $48. So I'm going to fill in that part of my ratio table. Use a ratio table to determine how much Lamika will pay to buy 8 more packs. So I want to go down here to 8. I can go from 48 to 8. Right? If I know my times tables, right, I'm dividing by 6. So to make an equivalent ratio, I'm going to divide by 6 here. That's going to give me 2. So it would cost, I would be able to get 2 juice boxes, right? It says, how much will Lamika pay to buy 8 more packs? Oh, that's my bad, right? That's my mistake. So let me erase that and start that over again, right? Because we want this to be an 8. And if I want that to be an 8, I can't go from 12 to 8. So I have to scale back first. So I'm going to divide by, let's see, what can I divide that by? I could divide by 4. Right? If I divide by 4, that's going to be 3. I could divide by 3. So let's divide by 3. If I divide by 3, 12 divided by 3 is 4. So if I divide by 3 here, 14 divided, or 48 divided by 3 is going to be 16. Then we scale ahead, times 2. So this is times 2, and that's going to be 32. So it's going to be about $32 to buy 8 more packs of juice boxes. Okay, let's continue. Now, we're going to take a look at some ratio problems. Heritage Middle School has 150 students. 2 out of every 3 students in Mrs. Mason's class prefer gel toothpaste. Use this ratio to predict how many students in the entire school prefer gel toothpaste. Well, I think this is a prime candidate problem for a tape diagram. So let's try it. Now, 2 out of every 3 prefer. But if 2 out of every 3 prefer gel toothpaste, if 2 prefer gel toothpaste, how many out of 3 do not prefer gel toothpaste? Well, that would be 1, right? 2 out of every 3 mean 2 prefer, right? And these do not prefer. So prefer to not prefer is 2 to 1. So I'm going to set up a little tape diagram here. 2 to 1 would be prefer gel, right? Not prefer gel. Use this ratio to predict how many students are in the entire school. Well, 2 out of every 3 students prefer gel toothpaste. Right? 2 out of every 3. 2 out of every 3. Let's see. Use this ratio to predict how many students in the entire school prefer gel toothpaste. So we're looking for this ratio part here. Right? Well, there are 150 students, and we have 1, 2, 3 parts of our tape represent that 150 students. So that means the unit is going to be found by taking 150, dividing it by 3, and that means our unit is going to be 50. So once we know our unit is 50, the number of students out of 150 that would prefer would be 100, because 50 plus 50 would be 100. So 100 students would prefer the gel toothpaste there. All right, let's look at the next example. The ratio of the number of text messages sent by Lucas to the number of text messages sent by his sister is 3 to 4. Lucas sent 18 text messages. How many text messages did his sister send? Another problem where a tape diagram would be helpful. All right, so Lucas text messages to his sister. So Lucas' sister is 3, 1, 2, 3 to 4. 1, 2, 3, 4. You're told Lucas sent 18 text messages, which means these 3 units have to total his 18 text messages. When we take 18 and divide it by 3, it means that the unit here is going to be 6. Right? So I always like to fill in my units here. So if the unit is 6, how many text messages did his sister send? Well, his sister sent 4 units of 6, or 24 messages. Right? 24 messages for his sister. Let's continue. We have some problems where we're going to use some double number lines. The Millers drove 105 miles on 4 gallons of gas. At this rate, how many miles can they drive on 6 gallons of gas? Well, first we set up this double number line, right, which looks like this, and we have units on the top and the bottom. So we always want to start our double number line with 0 and 0, and then we're told 4 gallons, 105 miles. So we have 3 gallons, 2 gallons, 1 gallon, 5 gallons, right? And equal units here, this would be 6 gallons. Now the question is, how in the world do we get there? Well, first we want to scale back. I want to scale back to find the unit rate, which means we want to take 105 divided by 4, and that's going to give us 26.25 for the unit. So every gallon we go 26.25 miles. Then from 1 to 6 we can scale ahead, right? Because that's times 6. So I want to scale ahead, multiply the top part of my ratio by 6. That's where we get 157.5 miles for every 6 gallons. All right, let's try another one down here. There are 810 calories in 3 scoops of vanilla ice cream. So here's my 0, 0, 8, 10, and 3. 2, 1, 0. 4, 5, 6, 7. How many calories are there in 7 scoops? I want to do the same thing we did with this last problem. First, we're going to scale back to figure out the 1. Right? So I want to know 1. So I take 810, divide that by 3, and we're going to get the unit rate. 2 times 3 is 6. Subtract, we get 2. Bring down the 1. 7 times 3 is 21. Subtract, we get 0. Right? So that's going to be 270. Right? Let's draw that up here. Right? 270 calories for 1 scoop. Now I can scale ahead from 1 to 7 by multiplying that 1 by 7. So I want to scale ahead here, multiply the 270 by 7. Right, I'll do that on the side of my paper. 7 times 0 is 0. 7 times 7 is 49. Carry the 4. 7 times 2 is 14. And 4 is 18. So we get 1,890 calories for 7 scoops of ice cream. That ice cream better be worth it. All right? Calories, right? 1,890 calories in those 7 scoops. Right, here's another example. Jeremy drove 120 miles in 3 hours. At this rate, how many miles can he drive in 5 hours? Well, we can use a double number line. We can use a ratio table. I'm going to use a ratio table here. So we have miles. Then we have hours. And we have 120 miles in 3 hours. Well, I can't go directly from 3 to 5, right? So I'm going to have to scale backwards first. So let's scale back to 1. So if I take 120, divide that by 3, it's going to give me 40. 40 miles every hour. Then I can scale forward by multiplying that 1 by 5. I do the same thing with my numerator. 40 times 5. That's going to give me 200 miles in 5 hours. All right, let's try our next example. While resting, a human takes about 5 liters of air in 30 seconds. At this rate, how many liters of air does he take in 150 seconds? So we have liters and we have seconds. And we have 5 liters in 30 seconds. And I want to see, well, I want to go to 150 seconds. Well, here, I simply have to multiply 30 times 5 to get to my 150. So I'm going to multiply the numerator, or the top part of my ratio, by the same amount. 5 times 5 is 25. That'd be 25 liters in 150 seconds. Okay, and I think that's about it for our lesson today. All right, you guys can play around, a bit with that, and I hope that that's going to be helpful for you. All right, see you next time.